Hello everybody, my name is Michał Łęcicki, as you probably know, and I'm software engineer at Visuality. And today I want to continue the topic started by Marcin in his presentation about moving from the old Ruby on Rails application to the modern cloud-based solution. In my presentation, I want to focus on more specific use case that we have in the application and that is connected with specific feature, which includes using AWS simple email service with Lambda and some magic in between. So to give you some reminder about the application we are in. So as Marcin told us, it's a big Ruby on Rails application with lots of legacy code, but it works and it's widely used on daily basis. The application has many dependent services, and well, we started working in the application. Well, the slide presents a little pessimistic view of the application, and in fact, at the moment I started working on moving the feature I will be talking in a second to the cloud, the situation was slightly better. So there was already some job done and some refactoring done. So for example, the MySQL database was moved from the dedicated server into AWS RDS, or for example, file storage was also moved to the cloud to S3. Okay, so let me tell you about the feature which our migration includes. So first, from the user perspective. It's very basic. As a user of the system, you can write an email message. Well, that's not a rocket science, and it's a very common feature in many Ruby on Rails applications. But what's more, you as a user, you can see also email messages that comes to the system. So you not only create new messages, but you can also receive messages and you can see history of email messages. And in fact, this is the one of the most important features in the application, because this is what users of the system are doing all the time. And the number of emails that comes in and comes out is quite big. It's about 20,000 emails per day. Another thing worth to mention is that there are not only simple emails, simple communication between users, but there is also one special kind of the emails that it's not an ordinary communication between people, but is data import. So we know that if there is an email from specific email address, it consists of some data that needs to be processed in a completely different way than ordinary communication. So how it looks from the system perspective. As you can see, there are two sources of emails. Those emails come to Gmail account, and in the Gmail account there is a rule that is set up that says everything that comes to Gmail account should be forwarded to Postfix server. Postfix is an email server used on Unix based systems that is responsible for receiving emails and in our case, in storing emails in dedicated directory. So all those emails comes to specific directory, and then some Ruby scripts are invoked. And now we are home. When Ruby runs, it invokes another functions, another sidekick jobs maybe, and as a final result of processing those messages, we have a new entities in communications table. Well, it looks pretty simple, and that was the solution in the that was built on the dedicated server. It works pretty well, and as you can see, it's not so complex. So you may wonder, why do we even wanted to change that? Well, we had some trouble with this solution, and the main drawback of it is the fact that this solution cannot be copied if we want to go to the cloud. And we knew that the application will be eventually transferred into the cloud solution, so we needed to use something else. And there were also another issues with this setup. For example, some outdated dependencies for postfix, and just the plain fact that the postfix was configured like 10 years ago on this server and no one touches it anymore. So if we need to change something or introduce new feature connected to that, well, that was very risky for us. Also, some issues with deployments, like we needed to remember to manually stop those Ruby scripts every time we deploy new version of application. And the things like hard monitoring and reading logs from postfix was also a little troublesome. So we searched for a new solution, and we spent quite a lot of time for that. We had research, and we saw that there are many options. I don't want to dig into much details to describe each of those options. If you will have a question about those alternatives, I can answer after presentation. But our main conclusion after the research we made was that the service provided by AWS, which is simple email service, would fit our needs the best. Why? Well, we saw that simple email service is indeed quite simple to configure. Another thing was that we knew that we will be building the solution that is based on AWS, and having this email receiving also set up in AWS made the whole process much easier. It was very easy to connect it to another parts of the system. Also, it's quite cost effective. It's very cheap compared to other solutions that we were looking at. And last but not least is the fact that when we saw that probably this is the way we will be going, we decided to create a prototype to check if it's truly the solution for us. So we created a prototype, and it went pretty smooth. After 3 days, we had a very basic and simplified but working solution. So how does new solution look like? Well, this is it. And from first glance, you can say that it's much better than previous one because it's more colorful, right? But yeah, seriously, let's take a look what is happening here. So again, Gmail forwards emails, but not to postfix because we don't have postfix anymore. It forwards it to a simple email service. In simple email service, as I told you, it's quite simple, and it was configured that whenever, and the configuration of this service is very basic. You need to verify the domain, and once it's verified, then you can do everything. So, for example, in our case, we just added one email address, and we set up a rule that when there is a new email coming to this address, store it in the specified S3 bucket. Then, if there is a new entity in S3 bucket, we have a callback that invokes a Lambda. And this is a place some magic happens, because the Lambda is the most important part of the solution. So it's responsible for letting the system know that there is a new message and it needs to be processed. So the Lambda code is quite simple. It just takes this callback notification from S3 and it creates a new entry in the table with appropriate attributes. So it links. We have a link for S3 object to know where we should look at, and we have an email type, etc. So when that's done, well, it's all Ruby on Rails responsibility later on to check if there are new items in this table and to process them. And in fact, when we come up with this new solution, we saw that the whole process of the email importing should be divided into two parts. One is receiving email, and this is the part that is purely done in AWS. This going through simple email service, S3 buckets, and Lambda. And another part is responsible for taking those emails and doing something with them. So it's on the Ruby on Rails application side. We have a Sidekick work that is Sidekick job that is running every 10 minutes and which is checking for new items in the table. So yeah, once again, here we have receiving, and this is built on AWS, and we have a feeder mechanism that runs on Ruby on Rails application. And as you can see, the point of contact is this RDS, it's the table in database. Few more words about saving those email notifications, let's say. So Lambda is creating a new entry in email requests table, and it needs to save those attributes. It needs to save if the email that comes is ordinary communication email or if it's this special data import email. It needs to store S3 file link, and it needs to store some another additional attributes used by Sidekick, like started processing, finished processing, to let Sidekick know if those messages are being already processed or not. There is also Lambda request ID, which I will talk about in a second. So as I said, the Lambda is the most complex and complicated part of the whole architecture, and it took us the most of the time to set it up properly. So I can share the experience of that it was a little hard, and we expected that it should be easier because all AWS commercials says that you can create a Lambda within AWS console and save it and test it in 15 minutes. Yes, that's true. But when you need to create a production-ready solution, then it's more complex. So if you need to build a Lambda that connects to database, you need to add additional gems because we built our Lambda with Ruby. And if you need to add additional gems, then you need to have local environment that reflects the Lambda environment. So you need to use some serverless framework for that. And in overall, the development and local setup is not so easy. Also, as you may saw on the new architecture graph, we are transferring logs from Lambda to CloudWatch. And also CloudWatch is not so user-friendly. Checking logs there is not an easy job, I can say. Another fact is that AWS documentation says that it might be the case that if your Lambda is invoked by the callback from another service, there is a rare situation that the callback might be invoked more than once. So one email message that is stored in S3 bucket could possibly invoke two lambdas, and such email message could be imported into the system twice. That would be troublesome, and that's why we have this one additional column called Lambda request ID. We just ensure that this column is unique. So the second attempt of writing the item to database with the same email will fail. In Lambda, there is a really cool feature of versioning and making aliases, and we use it in this Lambda, we use it heavily, but on the other hand, it's very unintuitive, and every person that I show Lambda to is a little confused at the beginning, how to set up those versions and aliases. And the last problem we have was that the whole configuration of Lambda was really, really hard to put in Terraform. When we transformed all our configuration from this new solution into Terraform, it was pretty easy for other services, but Lambda was really painful. Okay, so quick summary. Here I showed you that the new solution that we built in the cloud works. Well, it works right now. It works for a year, and we didn't have much problems with this solution. It's very extendable. Well, it looks more complex than the previous solution, but the fact that it's all done within one provider in AWS makes it much easier. And if you understand what is happening, and if you understand the whole idea behind the new solution, then it's much easier to see what is really happening inside specific services. And the last thing, the infrastructure change that we made here forced us to rethink the whole architecture of the email importing. And that lead us to the solution with divided responsibilities. So we have a stack built on AWS, and we have another part which is a feeding mechanism based in Ruby on Rails application. But it's very extendable, and I can imagine that if we have a new type of email, for example, we could easily create a new microservice that will also read those emails, and adding such microservice will be quite easy and won't interfere with what we already have here. And that's it from my side. Thank you.